Hello everyone, this is Sandeep Singh. Welcome back once again in your favorite channel. I hope you are doing very well, and today we will going to discuss sure short questions, physics most important questions for your PUC, right? So, firstly, just tell me, audio and video is proper? Audio and video is proper. Is there any interruption? Then let me know in the chat box. Then after we will start the session. This is another session where we will going to discuss most important questions from physics. All right. These are the most important questions from physics. All right. So, we are doing this session in the same way as your paper in board examination. That is, firstly, we will discuss MCQs type questions. That is 1 marker question, then 2 marker question, then 3 marker, and then after 5 marker question. All right. Okay, fine. So, just put a thumbs up if you are ready with the questions, that is MCQs in format, right? So let me know, is there everything is going good? Okay. Yeah, obviously there is PDF link from where you can download the PDF after the session completed once, right? Done? Okay. Let's start the session. Just put a thumbs up. Then after we'll start the session. Yeah. Okay. Great. Let's begin the session. Before that, I again repeat the PDF link in description box. You may check the link once the session is completed, right? So, let's begin part A, that is 1 marker question. Part A, 1 marker question. Let's start. First question. Yeah. Let's start with very first question. This is the very simple question, right? The capacitance of a parallel plate capacitor does not depend. Parallel plate capacitor does not depend, right? Area plate, distance of the separation between the plates, dielectric constant of the medium between the plates, or charge on the plates, Yeah, you can type your correct option in chat box. Okay, that's great. Yeah, Srinivas first attempt, that is D. Nedya D. Okay, D. Okay, D is the correct one. That is charge on the plates. Right? This is basically C equals to epsilon naught times of A upon D. Right. Moving to next question. Yeah. The process of emission of electrons from metal surface by applying very strong electric field. Thermionic field emission, photoelectric emission, or secondary emission. Right. Very strong electric field. What it is? It is field emission. Right. In thermionic emission, there is a given some given temperature. Photoelectric emission, light falls on the metallic surface, and in secondary emission, this is due to fastest moving charge, right? Due to primary emission, right? So, B is the correct one. Now, moving to next. In N-type silicon, which of the following statement is true? Yeah. In N-type silicon, which of the following statement is true? N-type. Electrons are majority and trivalent atoms are the dopants. Electron is the majority. C. In N-type silicon, negative. That is electron majority. And. If you want to dope for the impure semiconductor, that is extrinsic type semiconductor, then use pentavalent type. Pentavalent type. Pentavalent type. That's why it's having 5 valencies, right? Pentavalent. Which of the electron is the majority and pentavalent? B is the correct one. B is the correct one. B is the correct one. Just wait, just wait. Holes are no. This one is the incorrect. B is the correct one. B is the correct one. Okay? Okay. Fine. Energy equivalent of 1 atomic mass unit. Energy equivalent of 1 atomic mass unit. 1 AMU. 1 AMU. 931.5 electron volt, 1 mega electron volt, 931.5 mega electron volt, or 1 electron volt. Which one is the correct? 931.5 mega electron. Right? All right. Okay. Now moving to next. The ratio of magnetization to magnetic intensity is called magnetization. See, this is magnetization to magnetic intensity. Magnetization to magnetic intensity. Relative permeability, absolute permeability, magnetic susceptibility, or permeability of free space. Or permeability of free space. Okay, it's someone called C. Okay. Nagma Patil C. Manish C. Okay. Okay. It is magnetic susceptibility. It is magnetic susceptibility. Yeah. Bhumi, correct answer. Bhumi, correct answer. Right. Now, moving to next question, that is question number 6. Select the wrong statement for LCR circuit. Wrong statement for LCR circuit. Right. The correct option is the wrong statement, right? Below resonant frequency, X is greater than XL. Above resonant frequency, X is less than XL. Or at resonant frequency, Z equals to R. Or below resonant frequency, XC less than XL. Which one is a wrong statement? That is incorrect one. Anyone try? Okay. Okay, fine. Below resonant frequency, XC less than XL. Below resonant frequency, XC less than XL. D option. C is the correct one. Someone called C. C is the correct one just because at resonant, Z equals to R, which is equals to 0. Right? At resonant condition, resistance of the circuit is 0. Okay, fine. Now moving to next. Balmer series lies in which spectrum? Balmer series lies in which spectrum? It's visible, ultraviolet, infrared, or X-ray. It's visible, ultraviolet, infrared, or X-ray. Just try once, then after we'll move to another question. Balmer series. Balmer series. Yeah, Manish, in previous question, wrong one asking. Yeah. In previous one question, wrong one asking, right? Okay. A is the correct one. It's visible light. Right? It's visible light. Done. Now, moving to next. A concave mirror is producing a real, inverted and magnified image at infinite distance. Then the object is, see, real and inverted, magnified at finite distance, sorry. At finite distance. Then what? At the principal focus of the mirror, beyond the center of curvature of the mirror, within the principal focus of the mirror, in between principal focus and center of curvature of the mirror. See, we'll discuss about concave. See, For concave mirror, as we all know about, see, this is pole, this is pole, this is focus, this is center of curvature. You know, from infinite to focus, from infinite to focus. Okay, let's see. From infinite to infinite and between infinite and C, image is small. At C, it's same size, and after C till P, it's enlarged. All right. Just remember this diagram for further many questions. It will help, right? See, if I'm talking about the nature, then from infinite to focus, it's a real and inverted. It's real and inverted. And from focus to pole, it's virtual and erect. Is it or not? Is it or not? Discussing about finite. Finite. You know, if object is at focus, then the final image is at infinity. But it's finite. So that at principal focus of the mirror, in this case, image is at infinite. Right. Beyond the center of curvature. Beyond the center of curvature, this one is going good. Right. Within the principal focus and the mirror, within the principal focus, it's virtual. It's virtual and erect. Right. Between the principal focus and the center of curvature of the mirror. Between the principal focus and center of curvature, between the principal focus and center of curvature, right? All right, all right. This one is also not correct, just because the mirror, then it will consider F and P. That's why it's incorrect. D is the correct one. D is the correct one. D is the correct one. Right. Yeah, Manish, I think. Yeah. Manish, see, select the wrong statement for LCR circuit. This is the wrong statement for LCR circuit. Alright? Okay. Now, moving to next. The power dissipated in AC circuit is maximum if it is containing only. Power, see. What about power dissipation? Power dissipation, as you know, in power dissipation, L and C is 0. P average is 0, just because P average, which is equals to IRMS into VRMS into cos phi, is it? And as we know, see, in L and C, there is the value of phi is pi by 2 and cos pi by 2 is 0. So that for maximum P average, phi should be 0 degree. So that cos 0 is equals to 1. Just because, as we know, maximum value of cos is 1. That is at 0 degree. Then what it is? Where is it possible? It is possible only with a resistance. Just because in resistance there is a no phase difference. Both are in same direction. Is it? Is it? No. 90% questions from this only. This is not. We considered 3 or 4, I think 4 sessions. 4 sessions, same like this. From which majority questions covered. Alright? Yeah. So, pure resistor. This is purely resistor. This is purely resistor. Is it? Yeah, that's great. Okay. Moving to next. The magnitude of electric dipole moment vector of an electric dipole is given by general expression with the symbol having their usual meaning. Alright? You know, P is a dipole moment. P is a dipole moment, electric dipole moment basically. Q is basically charge. And what about A? 2A basically is the distance between both charges. Alright? Then, you know, this is like this way. This is Q negative, Q positive, and the distance between these two is 2A basically. Then dipole moment is what? P equals to, as you know, Q into 2L, right? Moment is basically Q into 2L. 2A basically from here. Done. P equals to 2QA. C is the correct one. Yeah. C is the correct one. Unknown, someone who unknown. Right, right. Neda, C done. C done. Okay. Moving to next. Moving to next. Moving to next. Is there any problem? Till this question, you have any problem? I hope it's not. I hope it's not. So, moving to next. Okay. Okay. Next question. Question number 11. It's question number 11. That is, a light wave enters from air into glass. How will the energy of the wave be affected? See, energy affection. Decrease, increase, remains the same or independent? Decrease, increase, remains the same or independent? Okay, fine. Okay, that's great, Lisa. Rev Kumar, that's great. Okay. You meant to say decrease. Okay. Decrease. It decrease, right? Air to glass, that means moving to denser, right? Okay. Two metals. Now moving to next question. Two metals, A and B have work function 4 electron volt and 10 electron volt respectively. Which metal has higher threshold wavelength? See, higher threshold wavelength. Which having higher threshold wavelength? Which having higher threshold wavelength? Which having higher threshold wavelength? Okay, fine. Anyone? See. Light wave enters from air into glass, that means rarer to denser, right? So that it's moving towards to the normal, just because energy decreases, so that it bends towards to the normal, right? Okay, so it's metal A. Metal A. Metal A. Okay. Now moving to next. Find true statement. Okay. See, work function is equals to h nu naught. Work function is equals to h nu naught, right? So work function W upon 4 electron volt upon sorry. Work function is work function higher wavelength, right? Higher wavelength. See, if I'm considering this frequency, that is work function upon h, right? Work function upon h. Work function upon h. Okay, and nu equals to c upon lambda. Nu equals to c upon lambda, right? So nu upon nu is basically see here nu is basically c upon lambda, which is equals to, that is, if I'm taking reciprocal, this is upon hc. These are the constant one, right? So which having higher threshold wavelength, having 10 B. I think it's B. 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 Okay. Okay. Now moving to next. Find true statement. The value of the harmonic is equal to its contribution to waveform. The value of the harmonic is directly proportional to its contribution to the waveform. The value of the harmonic is independent of its contribution to the waveform. The value of the harmonic is inversely proportional to its contribution of the waveform. See, here is inversely proportional to, here is independent, directly proportional and equal. Right? Directly proportional and equal. It's inversely proportional. It's the value of harmonic is inversely proportional to contribution of waveform. Alright? Next. What is the frequency range for a speech signal? What is the frequency range for a speech signal? Frequency range for a speech signal. It's 20 to 20 kilohertz, 20 kilohertz to mega. It's 20 to 20 kilohertz. It's 20 to 20 kilohertz. Is it? Okay. Okay, fine. Now moving to 2-marker question, right? Now moving to 2-marker question. Is it? See, state Kirchhoff's law of electrical network. Kirchhoff's law of electrical network. As you know, Kirchhoff gives two laws, that is KCL and KVL. Speech signal, that means voice signal, right? Voice signal. Yeah, that is audible hearing range for human, right? Okay, fine. KCL and KVL. What is junction rule? That is first rule. Algebraic sum of the currents meeting at any junction in the circuit is 0. That is, if I am considering this is I1, from here this is I2, this is I3, then can I write I3 equals to I1 plus I2. I3 equals to I1 plus I2. This is how sum of I is equals to 0, which is I3 minus I1 minus I2 is 0, or you can say that I1 plus I2 minus I3, which is equals to 0. And the second one is the potential drop across the resistance and the sum of total potential is same, right? That is, the algebraic sum of EMF and voltage drop in resistors around any closed circuit or loop is 0. Summation of IR plus summation of IR, that is the potential drop on resistance, plus summation of EMF, which is equals to 0. And why is plus minus of? Just because EMFs always not in the proper manner, that is positive, negative, then positive, negative. Somewhere it is also like this way. So that using their signs, right? All right. Dikshita, it's for your learnings, but you can't write in this way, right? Yeah. This is good for your learning, but while you write in your answer sheet, then use proper format. All right. Okay. Now moving to next question. A parallel plate capacitor with air between the plates has capacitance C. What will be the capacitor if the distance between plates doubled, the space between C, as you know that capacitance, that is E equals to epsilon naught times of A by D. Alright, capacitance is C equals to epsilon naught times of A by D. Alright, so use first one, that is, if I am talking about A, the distance between plates doubled. C, capacitance is inversely proportional to D. If D becomes twice of D, then C will get C by 2. Is it or not? Is it or not? Is it or not? Now, moving to next, the space between the plates is filled with substance of dielectric constant phi. Space between the substance of dielectric constant phi. All right, yeah, it's basically K times of C is basically K times of C naught. That is C equals to 5 times of C naught, whatever the value is, right? Okay, C, this is K times of epsilon naught A by D. Okay, what is the magnetic susceptibility for which material it is low and positive? Right, it is low and positive. Firstly, we will going to discuss what is magnetic susceptibility. Right, see, magnetic susceptibility of material is defined as the ratio of magnetization developed in the material to the applied magnetization force. All right, that is M upon H. This question is also comes in the form of MCQs, right? Okay, and it's low and positive paramagnetic substance. It is low and positive in paramagnetic substance. All right. Okay. Now moving to next question. Till this question, everything is going okay. Till this question, everything is going okay. Is there any problem with anyone? Then just let me know in the chat box. Okay. Okay, fine. What is equality factor in LCR circuit? Write an expression for it. What is quality factor? Yeah, here's also quality factor. Okay, here's also quality factor. Quality factor is basically F naught upon F2 minus F. F naught is basically resonant frequency and F2 minus F1 is bandwidth. So resonant frequency, upon bandwidth is basically quality factor. So it's a ratio of resonant frequency upon bandwidth. It's a ratio of resonant frequency upon bandwidth. All right. Okay, fine. Draw the ray diagram of image formation in case of compound microscope. Image formation in compound microscope. See, in telescope or microscope, the only thing is to use objective piece in such a way that it can form an image which is real, inverted and enlarged between focus and optical center of eyepiece. See, this is basically objective piece. This is an object, right? This is FO, focus of objective piece, right? And some here FE, focus of eyepiece, and this is optical center of eyepiece. Now, what will happen? A ray from this end, right, moving this way, and another ray moving in this way. This is also FE, right? So just joining these two in this way, here intersection point, that is, if this is AB, then this is A dash B dash, and this is A double dash B double dash. This is the final image. It is visible only when we were present in this way, right? That means the final image is virtual, erect, in the manner of image A dash B dash, it's erect. In the manner of the object, it's inverted. Final image is inverted with respect to object, right? But it's virtual, erect, and enlarge. This is how microscope works, right? Okay. Okay. No, it's for second PU. It's for second PUC, right? It's for second PUC. If is there any correction, then it will update it. It will update it. Don't worry. Don't worry. Don't worry. Don't worry. Okay. Moving to next. Classify metal, semiconductors and insulators based on the band theory of solid with diagrams. See, as we know that on the basis of band theory, there is a valency band named just like VB and conduction band. CB. If the energy gap between valency band and conduction band is too much, that is insulator. If the energy band gap is slight, then it's semiconductor. And if they are overlapping or partially overlapped, then it's conductor, and completely overlapped, then it's semiconductor. Just like, see, in conductors, the valency band and conduction band are overlapped, that is EZ0, that is sodium metals. In semiconductors, the energy gap is small, less than 3 electron volt. And is there something? Okay. In insulator, energy gap is greater than 3 electron volt. All right. I just draw diagram. See, this is a VB and here is a CB. This is conduction band, this is valency band, this is potential barrier basically. This is potential barrier and the gap between this is forbidden energy band. Right? All right. For here, if I'm just considering electrons, and in conduction band it's holes. If electron and holes get combined, then conduction possible. This is the energy band gap is greater than 3 electron volt. 3 electron volt. That means it's insulator. If I'm considering same in electrons in valency band, conduction band, there is holes. This is potential barrier. For certain value of input potential, electrons, that means valency band and conduction band gets connected in such a way that potential barrier breaks. All right, and electron hole pairs gets. So here is energy gap less than 3 electron. And for conductor, this is semiconductor. All right. Let's see for conductor. In conductor, there is no gap. This is basically valency band, and this one is conduction, so that it's conductor. All right, all right. Yeah, obviously model paper is important. Model paper is important, and we will discuss. We already discussed one model paper, that is sample paper, basically official sample paper. We already discussed, and later on we will going to discuss remaining sample papers too. All right. Okay. Moving to next, state Huygens principle. Huygens principle, right? What Huygens say? See, as per Huygens, these are wavelets basically. As per Huygens, new wavefront is produced by the preceding one. That means every point is the source of new wavefront, and if tangent drawn at any point, if I'm drawing a tangent over here, I'm drawing a tangent over here, then it will give the direction of wavefront, right? See, every point on a given wavefront is a source of secondary wavelets. These secondary wavelets is spread in all direction with speed of wave, and secondary is the tangent drawn to all secondary wavelets represents the position of new wavefront. See, this tangent basically new wavefront. All right. Okay. Now moving to next part C. Part C. That is, there will 3 marker question, right? 3 marker question. Let's start 3 marker question. Everyone okay with 2 marker question? Everyone okay with 2 marker question? Okay, fine. Let's begin. 3 marker question. Mention 2 applications of infrared radiation. 2 application of infrared radiation. One of them is this one. This LED never glows, right? You see, glowing this LED. That is LED put it over your remote. It's not. But in camera it is visible. Just because it is IR. It is based on IR, infrared. Okay, it's based on infrared, right? Okay, Lisa, we were discussing in depth, right? If you guys want more, then let me know. Okay, remote switches of household electronic system. Infrared detectors are used to observe growth of corpse. Long distance of photography. Infrared lamps are used in physical therapy. Infrareds used in your CCTV cameras also. Okay, infrared used in CCTV cameras also. Okay. Now, assuming the expression for drift velocity, derive the expression for conductivity of material where symbols have usual meaning. Okay. See, this is a very important question, right? This is a very important question to find the relationship between drift current, current density, and electric current, right? These are very important questions, right? See, just consider, this is a conductor, where average velocity of electron is Vd, that is called drift velocity, due to this electric field intensity set up by this potential difference V. All right. Okay. See what I mean. If I'm applying potential difference across this conductor, then there will be a electric field intensity set up in this way, positive to negative, so that negative charge, that is electron, moving towards this positive charge with the velocity of Vd, that is called drift velocity. Is it? Okay, it's fine. So E is the electrical field, Vd is the drift velocity, V is the potential difference across wire, A is the area of cross section. This is basically A, area of cross section. This one we want to derive. Okay, fine. N is the number of electrons per unit volume. N is number of electrons per unit volume. Okay. E is the charge on one electron. Then current through conductor is what? I equals to, if you remember that I equals to Vna. It's VDENA. It's simplest way to learn this formula. I equals to Vna. VDENA. Okay. Now, as we know that, what is Vd? What is this Vd? This is drift velocity. And velocity is what? Drift velocity. Velocity is what? Velocity. See, velocity is basically displacement upon time. Displacement upon time. Now, just putting this displacement and time form in from drift velocity, from relaxation time, it is basically Vd equals to E tau upon. So just put Vd is E tau upon m. Now NaE square tau upon m times of E. As you know that J is what? I upon A. This is current density. So current density I upon A, that is Ne square tau upon m times of E. This term considered as sigma. That is sigma equals to Ne square tau upon m. This is sigma equals to Ne square tau upon m. This is also called vector form of Ohm's law. Just because, as you know, see, J is a vector quantity, sigma is a scalar quantity, and E is the vector quantity. This is also called vector form of Ohm's law. This is called vector form of Ohm's law. Is it? Okay, now moving to next. A closely wound solenoid 80 cm long has 5 layers of winding of 400 turns each. The diameter of the solenoid is 1.8 cm. If the current carried is 8 ampere, estimate the magnitude of B inside the solenoid near its center. At the center, basically B equals to mu naught times of Ni upon L. B equals to mu naught Ni upon L. Right? Magnetic field inside the solenoid near its center is B equals to mu naught times of Ni upon L. Now, everything is given in question, that is L, 80 centimeter, which is 0.8 meter. Now, what about N? There is a 400 turns each on the solenoid, and total number of turns on the solenoid N equals to 5 into 400, just because 5 layers of windings, and each having 400. That means 2000. N equals to 2000. Now, diameter of solenoid is 0.018 meter. Okay. Current carried by the solenoid is 8 ampere. So, B equals to mu naught times of Ni upon L. B equals to, just put it, B equals to mu naught times of Ni N, that means 2000, right? I that is 8 ampere upon L is 0.8. B equals to 2000 times of mu naught. 2000 times of mu naught. Right? See, mu naught equals to, basically mu naught upon 4 pi equals to 10 to the power minus 7. So that mu naught equals to how much? 10 to the power minus 7. It's basically 4 pi into 10 to the power minus 7. 10 to the power minus 7. So that this is 2000 into 4 pi into 10 to the power minus 7. This is 8 basically, and 30 considered here. So 8 pi into 10 to the power minus 4. Tesla. Okay, it's okay. It's okay. Okay, sir. Now it's okay. Now it's okay. Okay, it's fine. Is there any problem? Let me know in the chat box. If everything is going good, then just put a thumbs up. Just put a thumbs up in chat box, so I can realize you are alive, right? Okay. Okay, fine. Now, obtain the binding energy in mega electron volt of nitrogen nucleus given, see, mass is 14.00307 unit, and as you know, atomic number. Okay, fine. See, this is 14.00307 mu. Mass of proton basically 1.007825, and mass of neutron basically 1.008665 AMU. These are the values which you already know, right? Okay. I think it's blurred. Okay. Now I think visible. Comparatively, it's more visible. Clarity. Comparatively, it's more clear, right? Okay, fine. The nitrogen nucleus contains 7 protons and 7 neutrons. Alright? Nitrogen this way. 7 protons and 7 neutrons. Right. The binding energy of neutrons is 7 into mass of proton. Right? Number of protons into mass of proton plus number of electron into mass of electron. All right, minus of mass of complete atom in mega electron volt, mass in mega electron volt, that is 7 into mass of proton, 1.007825. Okay, plus 7 into 1.008665, that is mass of neutron, right? Minus 14.00307 into 931.5. Okay. To convert AMU to electron volt, multiply 931.5. After calculation, we will get 104.66 mega electron volt. 104.66 mega electron volt. Okay. Okay, fine. This is basically this is basically number of neutrons, mass of neutrons. Okay, sir. 2 coils are wound on the same iron rod so that flux generated by one also pass through the other. That is the case of mutual inductance. That is the case of mutual inductance where no flux leakage, just because one coil is wounded over the secondary in this way. See, another coil is in like this. The primary has 100 translate and the secondary has 200 turns. Okay, fine. Number of turns in primary is 100 and number of secondary turns is 200, right? When current 2 ampere, basically 2 ampere flows through the primary, that is primary, the flux in it is 2.5. Flux is 2.5 into 10 to the power minus 4 Weber. Determine the value of mutual inductance, that is M. Mutual inductance. We have to calculate mutual inductance. See, mutual inductance is basically number of turns in secondary. See, you can write here. Mutual inductance is number of turns in secondary in d phi s upon dip. Now we have to calculate these values. See, as you know that EMF across the secondary is number of turns in secondary d phi s upon dt, and in primary basically m dip upon dt. This is EMF on secondary, right? Okay. Now this is EMF, this is also EMF. Just compare these two. That is ns d phi s upon dt, which is equals to m dip upon dt. This is from the definition of mutual inductance. And this is from Faraday's law. Okay, fine. Now comparing these two, we will get m ns d phi s upon dip. Now ns is 200, d phi s is 2.5 into 10 to the power minus 4 minus 0. Just because this is d phi s, right? That is somewhere phi 2 minus phi 1. Phi 1 is 0. So that the value is same as 2.5 into 10 to the power minus 4 Weber. Okay. And what about dip? dip is basically I2 minus I1. Here is I2 is 2, but I1 is what? It's 0 only. That's why it's 2 only. So you just put all these values, that is m, which is equals to ns, that is 200, into d phi s, that is 2.5 into 10 to the power minus 4, upon dip, that is 2 ampere. Just cancel out. This is 100 times m, which is equals to 2.5 into 10 to the power minus 2. Is it Henry? Unit of mutual inductance is Henry. Is it? Okay, fine. Okay. Obtain the expression for balance condition for the Wheatstone network. This is one of the most important question for your PUC, right? This is one of the most important question. Balance condition. See, if we consider 4 resistances on each side of a rhombus and connected one of the diagonal with a potential difference V and another one with a galvanometer, right? Another one with galvanometer. Then this is PQRS. What it is? It is P upon R, which is equals to Q upon S. This is the balance condition. Right? Why it is used? It is used to find unknown resistance. If I'm considering this R, S is a variable resistance or unknown resistance, then what is the value of S? S is basically RQ upon P. You can write this one P upon Q equals to R upon S also. Right? Majorly it's written as PS equals to QR. Alright. See, if I'm considering I ampere of current moving from here, then it will break in two parts. There is two loops. Just apply KCL and solve this. See, 4 resistors PQRS connected in the form of Wheatstone bridge. This is, alright, current I2 here and I1 here. Now, just apply the loop rule. Just apply the loop rule. I1P, from here I1P plus I1G, alright, minus I2R. Minus I2R. Why it is? Just because I1 in this way and I2 in this way. If the conventional current is opposite to our direction, we are considering the loop in this way, right? So that I am moving from D to A, and actually current is from I to, actually from A to D, so that it's taken as negative. If the direction of conventional current and the loop is same, then it is taken as positive. If both are in opposite, then it is taken as negative. So that I1P minus I2R is equals to 0. That is IZ equals to 0. In balance condition, you know, in balance condition, no deflection across, no deflection in galvanometer. No deflection in galvanometer. If there is no deflection in galvanometer, then it is an open circuit. That's why I am considering it as an open, right? So the expression is I1P equals to I2R. Now in the same way, applying loop rule in loop DBCS. Just apply. See, I1 minus IG, I1 minus IZ, I1 minus IG in this, right, times of Q, minus of, just because I2 is moving from D to C, but I am moving from C to D, so that I2 plus IZ, I2 plus IZ, I2 and from here IZ. So current is I2 plus IZ. I2 plus Ig times of S minus Ig, G is 0, where this term is 0, then I1 Q minus I2 S, that is I1 Q equals to I2 S. If dividing these two, it will P upon Q equals to R upon S. Is it or not? Is it or not? Yeah, you can take I1, I2, I3, I4 also, right? If anyone having any doubt, then let me know. See, in simplest way, see, this is potential difference, this is a galvanometer. Now, I1 current, this way I2 current. Firstly, apply the rule PQRS, loop rule, that is I1P plus Ig times of G plus, okay, this is basically minus I2 times of R, which is equals to 0. This term is also 0 just because Iz is equals to 0. So that I1P, which is equals to I2R. This is equation number first. Now, considering in second loop, here current is, see, I1, here Ig. So that I1 minus Ig, alright, Iz from here I2, now the current from S is Iz plus I2. But if I'm considering the loop, then this one is positive, this one is negative, this one is also negative, alright. That means in loop 2, what it is? I1 minus Ig times of Q minus Ig plus I2 times of S minus Ig, which is Ig times of G, which is equals to 0. That means what? From here, I1 Q is equals to I2S. Just divided these two, I1 cancel, I2 cancel, then P upon Q is equals to R upon. Is it? Is it? Is it? Is it? Is it? Okay. Now moving to next. A charge of 8 microcoulomb is located at the origin. Calculate the work done taking a small charge of this much from a point P to a point Q. See, what they want to ask, a charge of 8 microcoulomb. This is basically 8 microcoulomb, right? That means 10 to the power minus 3 coulomb. This was charge at origin, right? Calculate the work done taking a small charge. This one, P, where it is? This is at 0, 0, 3. 0, 0, 3. Now also draw z-axis. Let me draw another diagram. See. Here Q1. This is called Q1. Okay, fine. This is point P, which is 0, 0, 3. Okay. To a point Q via 6, 0, 6, 9. 0, 6, 9. That means the x-axis 0. Y-axis and z-axis somewhere this is 0, 6, 9, right? 0, 6, 9. This is point R, and the point Q is at y-axis. Point Q is at y-axis, just because this is 0, 4, 0. So a charge is moving from here to here, then after here, right? So the net potential is basically, work done is basically force. Work done is basically force into displacement. Force into displacement. A force into displacement. Not considering distance, so that moving from here to here. No, not at all. Right? So that let's calculate. See, firstly, work done change equals to change in potential energy. So calculate U1 and U2. U1 and U2. And then after calculate U2 minus U1. This is the final answer. This is potential. See, U1 equals to what? 1 upon 4 pi epsilon naught Q1 Q2 upon R. 1 upon 4 pi epsilon naught Q1 Q2 upon R. See, 1 upon 4 pi epsilon naught is 9 into 10 raised to the power 9. What about Q1? 10 into 8 into 10. See, 8 into 10 raised to the power minus 3. This is Q1 located at origin. This is 8 into 10 to the power minus 3 located at origin. Now a small charge, that is minus 2 into 10 to the power minus 9, moving from 1 to second, but that is P to R. That is 3 into 10 to the power minus 2. That is 3 into 10 to the power minus 2. That is 3 into 10 to the power minus 2. This is basically U1. This is basically U1. Okay. Now, what about U2? This is basically U1. What about U2? 9 into 10 raised to the power 9, that is 1 upon 4 pi epsilon naught. 8 into 10 to the power minus 3, charge will be same, only the 4 into 10 to the power minus 2. Right? Then what it is? U2 minus U1, U2 minus U1. These are the common terms, only 1 upon 3 minus 1 upon 4. That is 9 into 8 into 2, 10 to the power minus 1, 1.12, 1.2 joule. 1.2 joule. Just because, see, this one cancel out. 10 to the power minus 2 cancel out 10 to the power minus 3, remaining is 10 to the power minus 1. So that 9, 8 and 2. Okay? Okay, fine. Now, moving to part D, that is 5 marker question. Moving to part D, 5 marker question. Is there any problem with anyone? Okay. 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 Moving to next. Okay, let's see 5-marker question. Let's see the 5-marker question. Okay, it's fine. What it is? It is derive the expression for electric field at a point on equatorial line on an electric dipole, right? As you know, see, due to electric dipole, these are two most important questions. One of them is at axial position if P is considering in the axis of dipole, right? That is E equals to 2kq upon r cube. Is it or not? E equals to 2kq upon r square. This is at equatorial. This is at axial position. This is at axial position. And here asking equatorial position. In equatorial position, this is Q negative, Q positive. This is the perpendicular bisector P. P is the point at perpendicular bisector of this dipole. Is it? Now, electric field intensity is kq upon r square, r cube. Kp upon r cube. Newton per. So, we have to derive this one. But these two are most important question. Always remember, these are most important questions. Okay, let's see. Okay, it's fine. See, let's derive. Derivation for electric field intensity due to a dipole in equatorial position. Let's start. See, first consider the diagram. That is, this is dipole, this is Q negative, Q positive, and this is Q negative. Is it okay? If I'm considering the distance between these two is 2L, so the distance from Q positive to O is L, and this one is also L. Is it? Just mark P. P is a point at equatorial position. Equatorial position, that means it's a perpendicular bisector, right? And what is perpendicular bisector? The locus of all the points, the locus of a point which is equidistances from both the end. So that if I'm considering a Q naught positive charge at P, as you know that if you want to calculate electric field intensity at any point, then consider a unit positive test charge at that point, right? If you want to calculate electric potential at any point, then consider a unit positive test charge at that point. So let's consider unit positive test charge at point P. So this is Q positive and here is Q not positive. Both repel each other. That's why electric field intensity due to Q positive, it's just like this. This is EQ positive. But as we know that if some vector acting on the theta angle, there will be two components, that is horizontal component EQ positive cos theta and vertical component, that is EQ positive sin theta. Is it? EQ positive is basically symbol. Don't take like this. No, I'm not writing this. I'm just writing this is EQ positive sin theta. Okay. This is EQ positive sin theta. Okay. This is the basically angle theta. Now in the same way, this is Q negative and at P there will be a unit positive test charge. So that this Q negative just attract that charge in this way. Again here is an angle form theta. And both angles are same just because these distances are same. Just because P is at perpendicular bisector. Right? That is equidistances from both the ends. So if I'm taking this one is EQ negative, then there is a two components in like this, EQ negative sine theta, and in this way EQ negative cos theta. Now see, let be a dipole of two equal and opposite polarity of charges kept at 2L distance, right, at 2L distance. Now consider a unit positive test charge at point P, which is at equatorial position, with dipole AB. So electric field intensity at point P due to Q positive. See, if I'm considering this PO is R, then what about this distance? This is L square plus R square from Pythagorean theorem. This is also R square plus L square or L square plus R square. All right. Okay, it's fine. So EQ positive is KQ upon R square. That means under root of L square plus R square whole square, which means EQ positive is KQ upon L square plus R square. Is it? This is equation number first. Similarly, due to EQ negative, due to Q negative, what it is? EQ negative is equals to KQ upon R square plus L square. This is equation number second. From equation first and second, EQ positive, which is equals to EQ negative, let's consider E. Okay, this is equation number third. But EQ positive and EQ negative acting at point P with an angle of theta, so that net vertical component, that is EV net, see in the diagram, EV net, how it will calculate? See, EV net, EQ positive in upward direction, EQ negative in downward direction, and EQ positive and EQ negative are same. That's why these are cancel out each other. See, EQ positive sine theta minus EQ negative cos theta, from equation third, EQ positive which is equals to EQ negative which is equals to E, that means E vertical net which is equals to 0. E vertical net is equals to 0. Alright? Now, net horizontal component. That is EH net. How it will calculate? See, EQ negative cos theta and EQ positive cos theta, both are in the same direction. That means these are added together. Alright? So that E net equals to EQ positive sine theta plus EQ negative sine theta. Sorry. cos theta plus EQ negative cos theta. Alright. From equation third, these are equal. That means EH net, which is equals to 2E cos theta. From equation first, E equals to KQ upon R square plus L square. And from diagram, what is the value of cos theta? That is C. This is theta, this is L. So cos theta is basically base upon hypotenuse, And what is the value of base? Base is L. So that it's L upon under root of L square plus R square. L upon under root of L square plus R square. So L upon under root of R square plus L square. Now, just put all this value, E net basically 2E, 2 times of 2kp upon R square plus L square. 2kp upon R square plus L square times of L upon R square plus L square raised to the power 1 upon 2. Is it? Under root, can I written as this under root as like 1 upon 2, power 1 upon 2? This is under root 2, that means power 1 upon 2. Now, as we know that since 2 something, this is 2, this is 2kq. Okay. Is there something? Okay, just wait. Camera battery is just down, so that it's turned off. Now it's okay. See what it is. As we know that 2ql, which is equals to p, this is dipole moment. Electric dipole moment, right? This is electric dipole moment, right? This is electric dipole. Now just put it, E net, which is equals to this 2ql considered as p. 2ql is considered as p, is it? Okay. So this is kp upon this one, R square plus L square raised to 1 upon 2 plus 1, that is 3 upon 2. 1 plus 1 upon 2, that is 3 upon 2. Just wait one more minute. I think something wrong with camera. So just wait. One more minute. Okay, sir. Now it will be okay. Okay. I'm holding for 2 or 3 seconds. So see. Let's consider if R is much greater than L. L, that is the half of the length of dipole, which is too much small as compared to R. R is the realistic distance, but L is just very small. If L is very small, then what about L square? L square is negligible. Just taken as just like this. See, if I'm taking L equals to 0.2 and considering L square, then it is 0.04. As you know, 0.04 is smaller than 0.2. If I'm taking 0.2 in 2 digits, then it will be 0.20. And this is 0.04. That means L square is just smaller than L. So square of decimal value is much smaller than the exact value, right? So that it will be negligible. So E net is equals to Kp upon, see, R square raised to the power 3 upon 2. Then 2 cancel out. E net, which is equals to Kp upon R cube. And unit is Newton per coulomb. Unit is Newton per coulomb. Is it? Is it? Anyone having any doubt with this derivation, then let me know. Anyone having any doubt with this derivation, then let me know. It is very important. It is very important. Okay. Okay, it's fine. I don't think that's anyone having any problem. So let's move on next question. Let's moving on next question. Let's moving on next question. Okay, that's great. Teju, Manish, Lisa, that's great. That's great. Okay. Now moving to next question. What it is? A circuit connecting an 80 millihenry inductor and 60 microfarad capacitor in series is connected to 230 volt 50 hertz supply. The resistance of circuit is negligible. That means it's a resonant condition. I think it's a resonant condition if resistance is negligible, right? Okay. Okay. So obtain the current, amplitude, and it's RN. No, I think it's RMS values. Okay, it's current, amplitude, and RMS values. Obtain the RMS values and potential drops across each element. What is the average power transfer to the inductor? What is the average power transfer to the capacitor? Can I written as these two is 0? Okay. What is the total average power absorbed by this circuit? It will also 0. Right? It will also 0. Then let's calculate only the VRMS, IRMS, V0 and I0. Okay. So see, L equals to 80 into 10 to the power minus 3, just because it's millihenry, and this is picofarad, that means 10 to the power minus 6 farad, right? EMF is 230, EMF is basically 230, and frequency is 50 hertz. Frequency is 50 hertz. So firstly calculate IRMS. Okay. Okay. Then what it is? What it is? It is EMF upon omega L minus 1 upon omega C. EMF minus omega L minus 1 upon omega C. So this is 2 pi FL, this is 1 upon C. Everyone knows omega is equals to 2 pi F or 2 pi nu basically frequency. That is omega is L is 2 pi FL, and what about 1 upon omega C, which is equals to 1 upon 2 pi FC. So just put all these values and calculate. Calculation part is yours, right? Okay. Yeah, I'm super confident on you that you can calculate, right? That is, see, omega, that is 2 pi FL. 2 pi is just consider 2 pi or 2 into 3.14. And what about F? This is 50. And what about L? L is 80 into 10 to the power minus 3. Firstly calculate separately, then put in this format, right? 1 upon 2 into 3.14, that is F into 50 into what about C? C is 60 into 10 to the power minus 6. Now just put it here and solve it. Then the 8.24 ampere. 8.24 ampere. Right? Right? And these are basically magnitudes of 25.13 minus 53.0. Right? Magnitude only, just because from here it will negative value. That's why we'll consider magnitude only. Now, as you know that I0 is equals to how much? Root 2 times of IRMS, or you can learn IRMS, that is equals to I naught upon root 2, that is VRMS, that is equals to V naught upon root 2. So just put it, root 2 into IV, that is 8.25. We already discussed about this, 8.25. Just put it here, and this is I naught. This is the peak value. This is the peak value. In the same way, you have to calculate RMS potential drop across L, that is IV omega L, IV omega L, IV omega L, omega L. That's why I am calculating this omega L separately. Just because you have to put the value of this one directly here. Okay, and you will get 207.1 volt. RMS potential drop, that is across capacitor, that is IV into 1 upon omega C. Now again, IV into 1 upon omega C, this value you may use directly here also, right? And IV 8.24, right? 8.24 and IV, that is 437.1, right? As you know, power loss 0, and overall power loss is also 0. Is it? Calculation is at your own end, right? Okay. Two lenses of power 15 diopter and -5 diopter are connect with each other, forming a combination of lens, right? Combination of lens. What is the focal length of the combination? See, as you know that power equals to P1 plus P2, is it? So that P1 is 15 plus minus of 5, which means P equals to 10 diopter. That means what about focus? This is F equals to 1 upon P, 1 upon 10. That is 0.1 meter. That is 0.1 meter. Right? Or you can say 10 centimeter. You can say 10 centimeter. Okay, it's fine. An object size 3 centimeter placed at 30 centimeter from the combination of lens. Calculate the position of size and the image. See, you have the value. See, this is basically 100 upon 10, that is 10 centimeter. Why I will calculate in centimeter? Just because in next question values are in centimeter, so that we can also calculate. See, F, which is equals to 10 centimeter, that is positive. That is positive. That means this combination basically same like a convex lens. This is positive power, that is it behaves like a convex. Just because convex lens having dominating factor, that is 15 diopter, and only 5 diopter, that is concave lens. So concave lens reduces the power of convex by 5 times, right? So F equals to 10 centimeter. Size of object, height of object is 3 centimeter. Okay. Place in front of a combination of lens, that is U equals to minus of 30 centimeter. Okay. Calculate V and calculate HI. Calculate V and calculate HI. So F which is equals to 10 centimeter. 10 centimeter. Height of object is 3 centimeter. And U, that is equals to minus of 30 centimeter, if I am not wrong. This is minus 30 centimeter, that is V and height of image. See, from lens equation, what it is, 1 upon F equals to 1 upon V minus 1 upon U. In lens we'll use negative. In mirror it will be 1 upon V plus 1 upon U. To remember these concepts, just use lens less, mirror more, alright, mirror more, so that here positive 1 upon U, and in lens this is less, that's why it's used negative 1 upon U, right? If anyone having any confusion related where it will be negative or positive, then use this concept, that is mirror more and lens less. Is it? Okay. 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 So 1 upon f, which is equals to 1 upon v minus of 1 upon u, that is 1 upon f, that is 1 upon 10, 1 upon v, we have to calculate 1 upon u, that is minus of 30. U is always negative, right? Now, this negative positive, that means 1 upon 10, and this will positive, that means 1 upon 30, which is equals to 1 upon v. Now, 1 upon 30, 3 minus 1, that is equals to 1 upon v, that is 2 upon 30, that is equals to 1 upon v, which means v equals to 15 centimeter. V equals to 15 centimeter. And just see now, just see. What is the condition? Optical center. Focus is just 10 centimeter, right? Object is at 30. Object is at 30. That means radius of curvature. This is focus. This is radius of curvature. Radius of curvature is at 20. This is the value of u. This is the second condition. If object beyond the center of curvature, right, or object beyond the twice of focus, right, then image formed between f and twice of f dash. This is basically 10, this is basically 20. Just see, this is 15, this is 15. This is the value of v. Okay, so from magnification, as you know, magnification is equals to v upon u. This is positive. In mirror, this is basically m equals to negative of v upon u, that is equals to height of image upon my height of object. Alright. But in lens, this is positive of v upon u, right? So, let's calculate v upon u, that is equals to hi upon ho. V is basically 15, u is basically negative of 30. Hi, we have to calculate ho, that is 3 centimeter. Now, hi, which is equals to 15 into 3 upon negative of 30. 10 times, that is height of image equals to negative of 1.5. See, again, what we conclude from this answer, this negative source, real and inverted, and 1.5 source, a small image, dimens image. Height of object is basically 3 centimeter, but height of image is only just 1.5. Right? Okay. Yeah. Basically, we are meeting in examination time, so I don't have much time to discuss with the concept chapter wise. Else, I have a lot of jingles, right, and lot of synchronizing patterns, so that you can easily learn formulations. Okay, so now moving to next, that is second point. A glass prism has a minimum angle of deviation of 5 in air, right? State with the reason how the angle of minimum deviation will change the prism is immersed in a liquid of refractive index greater than 1. See, as we know that second one, right? As we know that mu, which is equals to sine del m plus a upon 2 whole upon sine a upon. Is it? There is a value del m is equals to 5. And considering mu greater than 1. Okay. Then what it is, see, when the prism is immersed in a liquid refractive index greater than 1, its refractive index with respect to liquid will become less than P, right? Less than P. From the above relation, it follows that the angle of minimum deviation will decrease. Alright? If you will increase the value of refractive index, which is always greater than 1 for any of the medium other than air, right? Mu is 1 for air only, right? Else, for each and every medium, refractive index is always greater than 1, right? Just because, see, mu is basically C upon V. C is the speed of light. C is the speed of light. See the speed of light in air or vacuum. And this is the speed of light. SOL is basically speed of light in medium. As you know that maximum speed is 3 into 10 to the power 8, which is C, which is in air or vacuum. If this one is the maximum value, see, if I'm considering C is greater than or equals to V, then mu is always greater than or equals to 1. Is it or not? Okay. So, in each case, it will decrease. It will decrease. It will decrease. Okay, fine. Kannada, just wait 5 more minutes. I think this is the last one. This is the last one. Just wait 5 more minutes. Then after you can leave. Okay, fine. See, a storage battery of 8 volt. Okay, let's say, and internal resistance 0.5 is being charged by a 120 volt DC supply using a series resistor of 15.5 ohm. What is the terminal voltage of the battery during the charging? What is the purpose of having a series resistor in charging circuit in the given circuit, assuming point A to be to be zero potential? This is at zero potential. Okay, this is at ground. Use Kirchhoff rule to determine. This is very simple. This is at zero potential. This is at zero potential. So use KVL. Use KVL, right? See, E equals to V plus I R plus R. E equals to V plus I external resistance plus internal resistance. That means if I'm considering E minus V equals to I R plus R. That is I equals to what? E minus V upon R plus R. Right? EMF minus potential difference upon external resistance plus internal resistance. Right? So just put it. External resistance 120, EMF is 120 and the potential difference is 8 upon resistance is 15.5 plus internal resistance is given 0.5. 120 this is 112 and 15.5 this is 16, right? 16 7 times, that is 7 ampere. That is 7 ampere. So terminal voltage is basically 8 into 7.05. 8 is the potential and 7 into 7 is the current into, see, this is basically, this is how this one. The resistance of this is 0.5 and this is 8 volt. So terminal potential, calculating potential across these combination. So that what? This is 8 volt and this is 7 into 0.5. 7 ampere current from here. Right? Okay. The series resistor limits the current drawn from the external source. In its absence, the current will dangerously high. Right? In series combination, if you are using a resistor, then it will control the current, right? The purpose of having a series resistor in charging circuit to limit the current drawn by the storage battery from the supply. In its absence, the current during the charging will be dangerously high. All right? Okay. Now, I think these are 2 questions. Now, apply Kirchhoff's rule, and you can calculate the value. That is, just consider this terminal at 2 volt. So, 2 minus 0, V equals to IR. Then you have to calculate I equals to V upon R. That is what? See, if I'm considering at this node in this way, this is 2, right? minus 1 upon 2 minus 1 upon, this is the 1. And I'm considering in this way, this is 2 minus of 1 upon this resistance R. Alright, compare these and you can solve. Right? Okay. Describe with the suitable block diagram action of PN junction diode under forward and reverse bias condition. Okay. Yeah, you can use KVL also. You can use KCL. You can solve in this way, or you may solve. See. Just apply L1 and L2. Two equation. You have two equation and you can solve it. Two equation and you can solve it. Right? Okay. Can I skip the calculation portion? I hope you can calculate. So I can just skip the calculation portion. If there is any problem, then let me know in next session, right? Okay. Describe with the suitable block diagram action of PN junction diode under the forward and reverse bias direction. See, what is PN junction diode basically? As you know that this is a potential barrier. See, this is basically potential barrier. This is P type and this is N type semiconductor, right? P type, that means majority charge carriers are holes, and in N type minority charge carriers is holes. Here minority charge carriers is electron and here majority charge carriers is electron. Is it? This is PN junction diode. This is what this is called potential barrier. Now if I'm taking connection of positive terminal with P type and negative terminal with N type, then it is called forward bias. This is basically forward bias. And in this condition, what it is, see, what is going, see, due to this positive, these holes are repelled towards 2. Put one more thing. This is basically depletion layer. This is basically depletion layer where electron holes combinations possible, right? So what I'm considering, due to this positive, these holes are moving towards to the potential barrier, and due to this negative, these electrons are also moving towards the potential barrier. See, holes in this way, electrons in this way, then what is going on here at depletion layer? Depletion layer will get decreased. Depletion layer will get decreased, and after a certain value of potential, that is called cut-off potential, VC, cut-off potential. It will break the potential barrier. Hence, conduction occurred. Alright. Positive terminal just pushes the positive, that is holes, towards to the depletion layer. Electrons is also repelled by the negative charges towards to depletion layer, so that depletion layer get decreases. After certain value, it will electron and hole pairs recombinations possible, right? So if I'm considering a VI characteristics, Vi characteristics, then what it is? This is V, this is I. Vi characteristics. For the certain value, there will be no current. That means in this way. This is called VC. This is cutoff voltage. Before cutoff voltage, no conduction. No conduction. Before this, no conduction. After this, conduction possible. After this, conduction possible. Before cutoff voltage, there will be no conduction. That is C. There is no current. After this value, suddenly current occur. Just because after the certain value, that is cutoff voltage, new electrons and hole pairs are generated, so that we have current increase in this way, not a linear increment. As you know that in conductor, what it is, the resistance was in a straight line format. That is, resistance is constant, but here it is not possible. See, for the smaller change of potential difference, there will be a lot of change in conduction. For a smaller change in potential difference, that means what? For a small change in this potential difference across this PN junction diode, that means if we increase the potential difference across this PN junction in forward bias, there will be certain increment in the conduction. Certain increment in the conduction. Right? Right? Yeah. So, here is less resistance. Now, if I'm considering the same thing, okay, symbolic representation of PN junction diode in forward bias, it's just like this. This is the symbolic representation. This is the symbolic representation. This is the circuit diagram basically, and this is working, how it will work. This is called VI characteristics. This is 5-marker question, so it's essay type question, right? So you have to write all these points. Now I'm considering reverse bias direction. A reverse bias condition. In reverse bias condition, you have to reverse the connection. That is, P-type material is now connected with negative terminal of the potential difference. This is P-type, this is N-type, and this is basically depletion layer, and this is potential barrier. This is potential barrier, right? See, in P-type, majority charge carriers are holes, and in N-type, minority charge carriers are holes. In reverse bias, minority charge carriers also play a vital role. So let's consider these are the minority charge carriers, right? These are majority charge carriers in N-type, right? Okay. This P-type and N-type are basically extrinsic type semiconductor. Just because, as you know, in intrinsic semiconductor, number of holes and number of electrons are same. So that there is no use of intrinsic semiconductor in real life. So that we use doping. If we doped with pentavalent impurity, then we will get N-type. And if we dope with trivalent impurity, then we will get P-type. Alright? Okay, fine. Let's see. Now, negative terminal connected with P-type, so that what will be happen? See, these all the majority charge carriers moving outside from depletion layer. In the same way, this positive attracts all these negative charges in outward direction, so that what will be happen? See, if P-type semiconductor material connected with negative terminal and N-type semiconductor material connected with positive terminal, then what will be happen? See, depletion layer gets increased. Depletion layer gets increased. Depletion layer, see, depletion layer, this is depletion layer get increased. This moving this way, this is moving this way, then it will get increased. An increment of depletion layer, that means higher of resistance. That is the value of resistance increases, so that if value of resistance increase, that means heat produced, so that heat produced. As you know that if resistance high in electrical circuit, that is lead to introduce heat. So heat produced, and due to this heat, there will be more electron and hole pairs generated. How it will happen? Just because semiconductor device, PN junction diode, or in semiconductor device, that is you can say p-type or n-type material, there is covalent bond. With rise of temperature, covalent bonds break. If covalent bonds break, one of them is treated as hole and another one is treated as negative charge carrier, that is electron, right? New electron hole pairs generated, hence suddenly higher current, that means uncontrolled current, current passing through semiconductor, that is called breakdown of diode. That is called breakdown of diode. That means diode will burn out. Okay. There is one important thing, that is current due to minority charge carriers occurred initially, right? See what it is. Depletion layer get increased. Due to increment of depletion layer, there will be a heat produced, and that heat generated more electron and hole pairs. That means I have this is basically VB, breakdown voltage. After this is uncontrolled current. Just because you just see, this is a straight line leading with current at infinite. That means after this potential, negative potential of VB, you don't have any control over the current. Here is you have control. See, from here to here, you can control the current. That's why using semiconductor instead of conductor, so that we can variate the current in the same conductor, right? But in reverse bias, after this it's breakdown. That means there is no use of that semiconductor, right? To protect this, we use higher doping concentration, that is called Zener diode, right? Especially designed for the reverse bias. That is, in Zener diode, this reverse bias characteristic just like this. There is some variation. You can variate it potential and you can get current accordingly. But here suddenly breakdown. And this is basically, this is the value of current. Here is the value of current is 0, but here is some value of current, that is current due to minority charge carrier, or reverse bias current also. It is also called reverse bias current also. See, what will be happen with this electron? This negative repels this electron, this positive repels this holes, and due to the breakdown condition, this electron and this hole recombination possible, but in minimum amount. Here electron hole recombination in majority charge carriers. That's why majority recombination. That's why I have this value, current of this value. But in reverse bias, only a shorten current, right? A minimum value of current. Okay. I think you got all these points. Right? VI characteristics of PN junction diode. And the symbolic representation of PN junction diode in reverse bias is just like this. This is symbolic representation. This is working. This is basically working. Is it? Anyone having any doubt in this question? Then let me know. Anyone having any doubt? Then let me know. I don't think anyone having any doubt, right? Okay. On demand. I'm just I'm just diving to depth, right? With you guys. I hope you all enjoy it a lot. I hope you all enjoying this dive, right? This is the kind of standard answer, right? That a model answer. Okay, this is VI characteristics. So, okay, it's fine. Now the time is to bind up this session. So just like the session, share the session, and subscribe the channel too. So I just give you congratulations also, right? Just because we are just 5K member, right? We are just 5K subscribers, right? So let moving forward, and hopefully in this month only we will at double digit, right? That is 10K subscribers in this month only. So just share and subscribe the channel. All right. Okay, fine. So we'll meet in next session. You may download the PDF notes of this session with the link given below in the description box, right? So we'll meet in another session. Bye bye. Thank you so much.